Welcome to aminacademy.com. In statistics, let us discuss about partition values. The partition values are the measure used in statistics for dividing the total number of observations of your distribution into certain number of equal parts. Commonly used partition values are quartiles, deciles, and percentiles. It is important here to note that the data should be sorted in either ascending or descending order before calculating the partition values. Usually data are given in disorder, not in order fashion, so you have to convert in ascending or descending order first. Quartiles divide the data into 4 equal parts. Deciles divide the data into 10 equal parts. And percentile divides the 100 equal parts. These partition values are used to fragment a distribution into smaller parts which are easier to measure, analyze, and understand. First, let us discuss about quartiles. The quartiles divides the data set into 4 equal parts. Already we know that there are 3 quartiles, that is the first quartile Q1, second quartile Q2, and third quartiles Q3, which divide the whole data into 4 equal parts with 1/4 of the data values in each part. That is Q1, Q2, Q3 are also called lower quartile, middle quartile, and upper quartile respectively. Look at this distribution here. That 100% is divided into 4 equal parts of 25% each. Minimum values here, maximum values here. The first quartile separates the first 1/4 part of the data from upper 3/4 part, that is 25% data will lie below Q1 and 75% will lie above it. Mathematical formula of Q1 is given below, where n is the total number of observation in the data set. Q1 is 1 into n plus 1 over 4th observation. The second quartile, which divides the data into 2 equal parts, it separates the first half of the data from its second half. That is 50% of the data lie below Q2 and remaining 50% lie above it. The second quartile, that means here the 50% above and 50% below, that is the median, that is the second quartile. The second quartile also called a median of the data. The median, that is Q2, second quartile is 2 into n plus 1 by 4th observation. Here 2 comes. Here third quartile Q3 separates the first 3 quarters of the data from the last quarter, that is 75% of the data will lie below Q3 and 25% will lie above it. Therefore Q3 formula is 3 into n plus 1 over 4th observation. Here we have to remember these points. First quartile Q1 is considered as the median. First quartile Q1 is considered as the median of the first half of the data. That means total data is divided by 2, then Q1 represents the median of the first half of the data. The quartile Q3 is considered as the median of the second half of a data. Suppose here this is the second half, in between this is a Q, that is Q3 is the median of the second half, also I can consider. The second quartile Q2 is of the distribution is equal to its median, that is second and that second part of the, that is Q3 is the distribution is equal to its median. Look at this example. The data set given below is 19 observations. Calculate all 3 quartiles and the interquartile range of the data. Here 19 observation is given. It is disorder. So first of all we have to arrange in ascending order. We arranged ascending order. Here the total observation n equal to 19. Now we will calculate the quartile using their formulas. Q1 equal to 1 multiplied Here 19 plus 1, that is n plus 1 by 4, we are using the formula, that is 19 plus 1 is 20 over 4, that is fifth observation. Here we have to calculate fifth observation in arranged order, that is 1, 2, 3, 4, 5. That 33 is the first quartile. Similarly, the formula I have to use Q2, then 10th observation is there. 10th observation is your Q2, second quartile. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 48. Similarly, Q3 you have to calculate. The interquartile range is Q3 minus Q1 is a formula, that is 61, that is third observation, Q3 minus first quartile Q1, that is 61 minus 33 is 28. This is the interquartile range. Now another example, calculate all three quartiles of this data. Here the total data, here 12 is given, 12 data are given, that is your further look at this data, 12 data. In this we have to arrange in ascending order. The total observation is 12. Here the quartile using respective formulas, Q1 equal to 1 into 12th observation plus 1, 13 by 4. Here 13 by 4 is 3.25. Here the decimal is there, the whole number is 3, that is third observation plus 0.25, next fourth observation minus third observation. Look at here, here the 48 is third observation, this is a 48 is a third observation, and that fraction 0.25 multiplied by fourth observation is 51 and third observation is 48. So 51 minus 48 is 3 into 0.25 plus 48 is 48.75. Here 48.75 is quartile, first quartile. This 48.75 is not in this set, but we have to understand because of the decimal place comes, so we have to consider our quartile, first quartile is 48.75. Similarly, Q2 equal to 2 into 12, n plus 1 by 4, which gives 26.4, 6.5, means 6 is the whole number, sixth observation is 60. Sixth observation is 60 and sixth minus fifth observation. Sixth observation, seventh observation is 62 and sixth observation is 60. So 62 minus 60 is 2. 2 into 0.5 is 1. 1 plus 60 is 61. Like this, Q3 also calculated, that is ninth observation, which comes here 9.75. So 9th observation plus 0.75, 10th observation minus 9th observation, which gives 69. Like this, we have done, so far we have done quartile, first quartile, second quartile, third quartile. For a whole number, directly you can calculate. For decimals, if you get that, suppose 3.25 means we have to get the whole number, third observation is 3. And 0.25 into next fourth observation minus third observation. Regarding that, you have to calculate. Next, deciles. Deciles are the partition value which divides a data set into 10 equal parts. Suppose some number of parts is given, you have to equally divide, that is 10 equal parts, and from that you have to calculate the things. There are 9 deciles denoted, D1, D2, D3 up to D9. Because that deciles is totally 10 parts, you have to 9 deciles denoted D1 to D9, and they are called as first decile, second decile up to 9th decile. For decile calculation, the data should be sorted into either ascending or descending order. We know that. Then first decile D1 is the point which has 10% of the observation, that is 10 by 100. 10% of the observation below it and 90% observation above it. That is, first decile is, first decile is 10% below and 90% above. Similarly, second decile is 20%, that is 20% below it and 80% above it. Similarly, up to ninth decile you can calculate. The fifth decile is same as median, because here totally decile means 10 parts, so D5 is the same as median because it divides the data into two equal parts. Mathematically, the deciles formula D1 is I into n plus 1 by 10th observation. I is D1 means I is 1, D2 is 2, like up to D9 is 9 here. Let's take some example to understand this concept. Look at this. Here example. Here below the table shows the scores of 100 students mathematical test score is given. Here 30 students, calculate out of 100, the mark is out of 100 for the 30 student is given. Here 15 students, here another 15 students, totally 30 students marks is given in disorder manner. We have to observe this in ordered fashion. That means here all, look at this, this is ascending order. Ascending order we split it. Here the total number of observation is total is n equal to 30. Now using the decile formula, D1 is 1, that is n is 1, 30 plus 1 by 10, 31 by 10, 3.1. That is third observation plus 0.1 into fourth observation minus third observation. Here third observation, look at this, this third observation is 47 and 47 plus 0.1 into fourth observation minus third observation, 49 minus 47. Look at this, 49 minus 47. Look at this formula. Here 0.7 is a whole number, third observation, 0.1 into 49 minus 47, that is 47.2. Like this, D4, D5, we can calculate up to D9. Deciles we calculate like here. The total, here note this point, fifth decile is equal to the median of the data. Totally 10 deciles are there. Fifth decile is 9 parts with 10 deciles. That is here fifth decile is equal to the median of the data. Here next total number of observation is even. The median, suppose so far we did even deciles here. Median is, the formula is n by 2 observation plus n by 2 plus 1th observation total divided by 2. So which is the median for this? Suppose 15th observation, n by 2 is 15th observation, next observation is 16th observation divided by 2. Here 15th observation is 67, 16th observation is 71, divided by 2 is 69. This is a D5. From the above example, we have calculated or interpreted that 10% of students have scored 47.2 or less. Here that is first decile. We can describe like, from the above example, we have concluded that interpreted that 10% of students have scored 47.2 less and 40% of students have scored 64.8 or less, and 50% of the students have scored 69 or less in the test. That means from the deciles you have to calculate less and more. Let's move towards the third partition value, percentage. Here you have to remember these points. Quartile is derived from the quarter, decile is derived from the decade, and percentile is derived from percentage. Now let us discuss about percentiles. Percentiles divides a distribution into 100 equal parts. It divides the complete data set into 100 groups of first 1% each, because total is 100%. There are total 99 percentiles denoted P1, P2, P3 up to P99, and they are known as first percentile, second percentile up to 99th percentile. Here it may be noted that the data should be sorted in either ascending or descending order. So far you have done like with magnitude from lower to higher. The kth percentage, the formula is that the value in a data set which splits the data into two parts. First, lower the part contains k percentage of the data. The upper part contains the rest of the data, which amounts to 100 minus k percent, where k is any number between 0 to 100. The 50th percentile is equal to the median of the data, which divides the series into two equal parts, because totally 100 parts. 50th percentile is the median of the distribution, and the 25th, 50th, 70th percentiles are also called the first quartile, second quartile, third quartile of this percentile respectively. Mathematically, the formula of ith percentile is pi is represented as formula. Look at here, pi equal to percentile any number is I into n plus 1 by 100th observation. Here I changes 1 to 99. Now let's understand the calculation of the percentile with the help of an example. Look at this example. The height of the students is 50 in centimeter for 50 first year students of a college are recorded and shared into table below. This table is given for 100 students, 50 students. Calculate the height of 30th and 46th and 90th percentile values of the given distribution. Here distribution is given. First of all, you have to write in ascending order in magnitudes. Look at it, 150.2, 150.4, 152 is increasing, right, left to right, horizontally. Now n is 50, you know that. P 9th to first, P 9th not P 30th. P30 you are calculating is 30. Total number of students is 50, that is 50, n plus 1 is 50 divided by 100, which gives 15.3. 15.3 is 15th observation plus 0.3 is 16th observation minus 15th observation. Same like before. So 157, that is 15th observation is 157. 157.7 this is the 15th observation, and 16th observation is 158.1 minus 157.7. Like you have to calculate everything. Therefore, the height in centimeter of 30th, 46th and 90th percentile value are this given. By calculation we got it. Application of a percentile in real world. Here, percentile has a variety of uses in everyday life. Whenever we have to analyze a large set of data by breaking it down into smaller parts, the percentile are helpful. The results of standardized tests such as for competitive exam is often reported as a percentile score. It helps in the performance comparison of an individual with other participants of the same test. Suppose some number of students written an exam, then we have to compare this particular student is how above to the other students, how below is to the other students. That means each and every person's performance you can calculate with compared to the other student. Often at a state or country level. Percentiles are often misunderstood with the percentages. Normally, don't misunderstand with percentage and percentile. A percentage represents a fraction of a whole, while percentile are used for relative comparison. For example, let's suppose a student has scored 80% in an exam. At first glance, it seems quite impressive. But when you come to know that the score of 80% corresponds to the 40th percentile in the class, that is 60% of the students in the class has scored more than 80%. That means that 80% of the mark of the individual student is 40th percentile, that is in the class 60% of the student in the class has scored more than 80%. Now the same score will look very ordinary. Percentage score does not tell you how well the student did compared to the other students. That means percentile tells the comparison of other students, how well he did that exam, we can understand. So percentage is more useful in competitive exams and some competitions we have done. Please subscribe our YouTube channel.